Good evening, everyone. As part of our Python learning journey, we are going to move to our next step. So in the last session, we have discussed exchanging information between two Python programs. That means in real time, they are going to be at two different nodes, right? Two different ECUs, right? So when it comes to simulation, we use programs as node, right? Each ECU will be simulated in a Python program. Then in between programs, we used to do a communication, right? We used different message exchange mechanism. Among them, we have chosen this one, RabbitMQ message queue for packet exchange, right? That is how we achieved. But in the last session, the one node was transmitting and other node is just receiving. That's all. There is no two-way communication. It is one-way communication. One is transmitting and another one is receiving. Now we are going to create a response simulation for a vehicle. In that, the each ECU will be transmitting as well as receiving. Right now, as we know that the CAN is a multi-master communication. When the channel is free, every node in the bus has equal rights to transmit if there is a message, right? So to transmit, right? So it is a multi-master broadcasting concept. So it should be now we have to implement that in our we are going to create a response simulation for that CAN network, right, using Python, right? So that is the goal. For that, I have a requirement here. This is a research requirement. This has been published in the internet widely. So we are using this as an example to create our own REST-based simulation using Python. Right. So this is the requirement. The requirement, this is a CAN project actually. This here we have four different modules. Instrument cluster. The instrument cluster is a ECU which used to be your car dashboard right now. There you will have a speedometer, tachometer, ECT gauge, and fuel gauge. Those things will be there. Along with that, the modern cars used to have a display in which you will see the odo, trip odo, and the warning messages, telltales, those stuffs. That is one ECU. The other ECU is ACC module, Automotive Cruise Control module. This is a new feature or ADAS feature available in advanced driver assistance system available in a modern car, so that using that you can do a self-drive in a highways, right? You can give the vehicle control to that module. The module used to drive in the highways. This is not suitable in the every places. Only in highways you can use this feature, right? So that is the second module. The third module is engine control module, which is nothing but a powertrain module that we used to have. So which controls the throttles, it is control the engine RPM and other stuff. So that is another issue, engine control module. The finally we have a brake control module, which is something related to which used to control the brakes and then compute the vehicle speed. Those works will be done by this module, right? So for each one of these module, we are going to have a Python program, right? So each one of them going to be one program. Then these programs going to exchange the messages. What they are going to exchange, right? So as per this diagram, they have given a thick black arrow for CAN, which means those where the CAN signals, those are exchanged in between modules. The instrument cluster is exchanging a CAN signal called Corice rich request and then a break switch one. These are the two CAN signals. It is going to transmit from the instrument cluster to ACC module. What for these signals and why they are used? and why they are exchanged, those information I will brief later point of time. As of now, you understand that these are the two CAN signal, those are going out from the instrument cluster and is received by ACC module. Again, the ACC module is transmitting a CAN signal to the instrument cluster, that is called as ACC driver information message, right? That is a CAN signal exchange from ACC module to instrument cluster, right? Not only that, the ACC module is exchanging, or it is transmitting two CAN signal to engine control module. They are ACC state and target speed. These two signals are transmitted from ACC to ECM. In turn, the ECM is also transmitting a CAN message called break switch 2. That is another CAN signal. The usage of this CAN signal, why they are transmitting it. So I'm not going to explain here this ACC module projects. My primary goal, my aim is just to help you to understand what are the CAN signals are exchanged in between these modules. And then we are going to develop a REST-based simulation for that, a basic baseline simulation using Python. Right, nothing more than that. So we will study about this project in detail later point of time. As of now, what we have to understand is what are the CAN signal exchanged in between these modules. Right, so the ACC module is exchanging ACC state and target speed to the ECM, and ECM in turn is exchanging or transmitting a CAN signal called break switch 2. Then we have a brake control module. The brake control module receives ACC state and brake deacceleration request signals from the ACC module. In turn, the BCM module is transmitting the vehicle speed to ACC module, and then the engine control module as well as the instrument cluster. By in real time, the instrument cluster is the one which used to display the vehicle speed. That is missing here. Let me update this diagram. So we need to have a arrow here. So it is displaying, it is transmitting, the brake control module transmitting, it computes the vehicle speed and then it transmits that vehicle speed to every other module that we have in the network. So we're going to have that as black, right, billion. So now this is the diagram that we have. For this, we are going to develop a RISC-based simulation using Python. Right. First, we are going to use our baseline module that we have before. We have two different module node, and that is transmit message module and then receive module. Those two modules we had, right? So let me show them their baseline code. So I believe it is here. I renamed that one. So here we have a transmit message module, right? So it used to transmit, and then we had another module called receive message. Receive, I believe that was, I renamed that to ACC, I believe, if I'm not wrong. Let me open that. It's just a receive code, right? When there is a message, they used to receive it from the queue and then they will display it. So like that we had. But now the each module going to do both, right? They are going to do transmission as well as reception, right? So the first module that we are going to develop is the BCM version 2. That means improved version of, we are going to convert our transmit message module into BCM module. The BCM module that we had previously in the last discussion used a queue, right? Now we are going to use an exchange in RabbitMQ. So the exchange is a mechanism using that you can transmit, broadcast messages using RabbitMQ. That's why I'm going for that. In order to achieve that, this is our transmit message function that we had before. That one used a queue before, right? We had a queue here, but instead of queue, this time we are going to use an exchange. The reason behind that is we are going to use RabbitMQ to transmit broadcast, sorry, not transmit, broadcast messages, right? That's why we go for that, because CAN is multi-master broadcasting concept, right? So for that, I have to create an exchange. That I created the exchange here called PubSub2. Instead of that, to make it very interesting or to understandable, so I can change this as BCM exchange. That would be great, no? Right? So it is a broadcasting one. That's why we selected fan out. Then we have a BCM message that we had, that we created before, right? We have ID for that. We have given ID as 110. So it is our choice, 11-bit identifier, that you can use whatever ID that you want. So after doing it, we are just converting that, because the BCM info is a dictionary. So we convert that into string. Then we transmit that string to that we are printing it, and then we are transmitting using the exchange. So the exchange is BCM exchange. Let me change that. Done. So right, when the BCM is transmitting, right? So after that, right, we are doing it, then we close the connection, right? Then we do this activity again and again, every as per the message periodicity. So the message periodicity here is 250 milliseconds. So that every 250 milliseconds, we are going to do that one. We are repeating it. Also, in the last discussion, we change the vehicle speed every 1 second in that packet. That is, for that, we are running in another thread, right? So this is only a transmission part that we had before. Now moving forward, this node going to receive as well. It is not only going to transmit, it is also going to receive when there is a message. So we just brought that receive message code or receive module that we had before, that code that we had in that module. No, that is brought here. We brought that code here, right? So the same thing. So here, what it is going to do, it is subscribing certain exchange. So when you want to listen some other module that we have in the network, you have to subscribe. That is requirement of RabbitMQ, right? As far as the CAN is concerned, when one is transmitting, others in the network are able to receive it. So in order to meet that one, we are subscribing for the broadcast that was done by other modules. What are the other modules that we have in the network other than BCM? So we have a ACC module, and then ECM module, and then ICM module. We have to subscribe to those exchange, only them. But to meet the CAN requirement, because the CAN is when one is transmitting, others are able to receive. Those are in the network. So to meet that requirement, we are we are right subscribing to meet that requirement in RabbitMQ. We are subscribing the exchange created by others. So what may be the exchange of ICM? I am going to name that as ICM exchange that we are going to do in future, but as of now we don't have. So I am just subscribing. Then we have another. We are going to have another exchange called ECM exchange. Right. So then we are subscribing to ECM exchange. What others we have? We do have ECM, BCM, and this is BCM module. No, ACC exchange. Right. So the exchange created by BCM is only BCM exchange. These are the others exchange to which the BCM has subscription. Subscription. When they are transmitting, this BCM module is able to receive them. Right. So like that it is. Okay. After that, when there is a message, it will be received and will be consumed by a BCM. If somebody is some other modules in the network is transmitting, it will be received and will be consumed, right? So for that, we have a code, right? So at the end, in the main, we have to transmit as well as receive. We have to transmit. We used to transmit the messages. Those are transmitted by BCM, and then we used to wait for incoming messages. Indefinite, that is indefinite wait. So we always wait for others message, right? Right. When we have to transmit, we are transmitting them in threads. Brilliant. So now we have a one module. We are going to simply copy paste these modules into four different one, right? Because we need to have an ACC module and then ICM module and ECM module like that. Let me first save as ICM. First, I am going to create an ICM module. As per this diagram, the instrument cluster is going to transmit Cori switch request and break switch 1. These are the two signals. Those are transmitted by instrument cluster right now. So I am going to rename this ECU name as is ICM, and then the network is same, and baud rate is this one, and we can say this message ICM message as 120. It is also cyclic. Let me define the periodicity as 150, and the data going to be here Cori switch request, right, as per the diagram. Cori switch request. Right, it is complete. Cori switch request. Then default value we can have 0, and then we have break switch 1. That is another signal that is also going to be 0 as default value. Okay, now we have two signals in this packet, and we are not going to have speech sample because that is only for BCM. So I command this line. Then again, this global index, speed index, those things were not needed. And we don't need this while loop random number generation for vehicle speed because we are not going to have vehicle speed here. And then the defining this function also not required. I just comment them. The transmit message, instead of BCM exchange, it is ICM exchange, right? Because ICM going to have ICM exchange. And we call this information as ICM info instead of BCM info. I call this as ICM info. Then we transmit that ICM info, right? Through ICM exchange, right? So then what is the periodicity? So it is like ICM info cycle time divided by 1000, which is nothing but 150 millisecond, right? Hmm. This thread is not going to be there. So, and then on message, the ICM is also going to subscribe the exchange of BCM, ECM, and ACC. So other modules, we are going to receive the information from other modules. That's why we just initialize that. And then we just wait for, we just consume when there is a message, we just receive it and consume it. That's all. After that, we have called transmit message on message. Brilliant. So now let me clean up the code. So I'm going to remove the things, those are not appropriate to ICM. So these things were not required. That will confuse people. So just I remove them. Here we can print, because what we are transmitting, no? I think we are for transmission, we should print that. Let me print it ICM info. And then this is not required. Right? So in BCM02, what we have while we are transmitting, BCM02. Are we printing that we are transmitting so and so? Interesting. So I think we are making, right. So we can say it here as well. You are creating result and we are printing result now. That's all. I think here it is not required then. So transmission we are printing. Right. We have a BCM printing as well as believe as we have here. This is not required. Sorry. Open wrong file. Here it is. I think I created VCM exchange and other things, right? Where I created them? Still in interesting. VCM exchange. Share. Right. Then ACM exchange and ECM exchange. Finally, ACC exchange. Right. So ACC exchange. Right. Right. So we have ICM BCM module code here. And this is, I think we can have only these two. We don't need others. That's why it is confusing. Close. Close all but this. Right, then we have to bring our other module, ACC, sorry, ICM, that we created now. Right, so this is ICM module. Okay, then the third module is ACC module. For that, we already have a code. We are going to just bring that and modify it. So it is ACC vehicle network. The message ID is 230. So it's not duplicating, right? 110. Here it is 120. It is 230. Right. So this is going to be ACC exchange. So it is ACC info. We print that. Then, so in the ACC info, we have what are the signals that we have in the ACC info? ACC driver info, brake deacceleration request, and target speed as per the diagram. See, ACC module is transmitting ACC driver info, ACC state, target speed, and then brake deacceleration request. Totally 1, 2, 3, 4. Right. 1, 2, 3, 4. Okay. These are the signal. All of them are going to have default value initially. Then we are transmitting them, as well as we are waiting for incoming message. But did we subscribe? I think right exchange, we didn't create like that. So let me subscribe to ACC going to have BCM exchange, and then we have ICM exchange. Finally, hmm, channel.exchange declare. I don't think this is needed. This line is needed. So it is going to just receive only. Only for transmitters, transmission it is needed. Let me check the BCM code. Only we need to declare bind exchanges. That's all. ECM exchange, ACC exchange. So we are binding the exchange with the queue. This is for ECM, we are doing it. Then we are doing it for ACC. Then we have to do it for ECM, ACC, ICM as well. Right. That's all. Right. We are subscribed to exchanges. In case of ICM, in exchange declare this is not required. We create a queue for ICM and then we bind that queue with ECM exchange, ACC exchange, and BCM exchange we have to do. Right. This is IC module. After that, ACC module, we have when there is a message, we declare a queue for ACC, and we are binding that queue is ICM exchange, and then this is for ICM exchange, this is for BCM exchange, and this is for ECM exchange, right? That's all. So these things were not needed. We are going to consume it. So we have all these things, but we don't have for ECM yet. File save as copy as, save a copy as. We have different meaning in Notepad++. So ECM version 2. Right, we open that ECM version 2. And we have to rename, right? ECM network is same. Here we are going to use 180 as message. This one going to have 200 milliseconds. The data going to be as per this diagram. It is transmitting only break switch 2. That's all. Break switch 2. Default value is 0. That's all. So, and then I am going to delete these signals. I call this as ECM info. Then while transmitting, I create a channel, and then I create an exchange called ECM exchange. And then I transmit my ECM info. After dumping it to a string, then I do a transmission. Right. So after doing it, I do repeat that stuff every ECM info cycle time, which is 200 milliseconds, right? So this is, after that, we have, when there is a message, I just create a connection to that, and I create a queue for ECM. After creating queue, I bind that queue with ICM exchange, BCM exchange, ECM exchange, because these are the other modules that we have in the network. So we just link the queue with them, because if they transmit, we will receive it. Right, that's all. Okay, the stage is set, the things are ready. Let me open a couple of terminals and then run all these programs independently. So first we already have a terminal here, right? Let me create another terminal. CMD D colon CD, and this is another terminal. So let me make them in a single screen so that we can see what they are doing. We can see what they are doing. And this is 2. Second terminal. Third terminal. Right. Right. Then finally, we need one more terminal. Right. We have 4 terminals ready. Each one of them going to run one node. Right. So here I am going to run Python BCM version 02.py. Interesting. Okay. It is a typo. So it is transmitting. Right. Then I have here Python ICM version 2.py. Right, it is transmitting is query switch request. This is transmitting is vehicle speed. Then Python. Here we are going to transmit Python. This is like ICM, BCM, ICM, ECM version 2.py. So it is transmitting. I think something going wrong here. Received. That means it is receiving the packets, but transmitting as well. Right. So it is transmitting as well as receiving, but these two are just transmitting, but I'm not finding any reception here. Right. Maybe let us do that. Let us see later point of time. Then we have Python. This is BCM, ICM, ECM, ACC. Why? So he's also transmitting and receiving. But the problem with these two guys, right, they are just transmitting, but they are not receiving. Maybe, see, I'm not finding any reception here. Let me investigate. Maybe we created, right? In ECM also, we declare, somewhere we make mistakes. Exchange, exchange, exchange. Okay, ACC is working fine. Then ICM, BCM, ECM. Okay, when it comes to ICM, ECM, maybe we have not created the queues when we run them. Because of that, it is creating issue, I believe. Let me terminate them and then rerun so that let us see whether they are doing it, because these two, Control C, this is BCM, no, I terminated the BCM, I terminated the ICM too, because ACC and ECMs are working fine, right? So this is like break switch request. This is like break switch. This is ACC, this is ECM, right? So let me bring receive ID 384. So it has the content break switch 2. Break switch 2. How can ECM can receive its own message? It is received. Let me stop it. I'm not agreeing. See, when it is receiving ID 384, data is break switch 2. Interesting. Transmitting break switch 2. How that is possible? There is a flaw. ICM exchange. Okay, ECM should not subscribe to its own exchange. It should be ACC exchange. ICM exchange, BCM exchange, ACC exchange. Then when it comes to ACC, it is ICM exchange, BCM exchange, ECM exchange. And it's come ICM, ECM exchange, ACC exchange, BCC exchange. BCM, ECM exchange, ACC exchange, ACC. Okay, now in RabbitMQ, these exchanges are already created. Now I believe it used to work fine. BCM version 2. Okay, it is only transmitting now. Then we have ICM here. So it's transmitting as well as the receiving. Vehicle speed is receiving. Okay, brilliant. Then it comes to ECM. So it is receiving vehicle speed, brake switch 2, right? Brake switch 2 should not be received by BCM, right? Because it is coming from, I think still I have an issue with ECM. Let me check that. Transmitting 384. When it is receiving, received ID 288, cross switch request, maybe from ICM it is receiving, and then received ID 272 is having vehicle speed, which is vehicle speed, and then this is having a cross switch request. that is ICM info, BCM info, right? The transmitting, okay, brilliant, correct only. Right, then here we have ACC. That's all. All modules are exchanging the packets between them. Okay, team, that's all for today. Like exchange message in between nodes, and we set up our first rest bus simulation. Okay, now, so let me explain more detail about simulation development using Python in upcoming session. Thank you for watching.